Hello and welcome to the Amazon Web Services Partner Webinar Series. Our topic today will cover how to optimize your Microsoft SharePoint 2013 solutions on AWS. I'm your host today. My name is Sherry Sullivan. I'm here with the Partner Marketing Team in Seattle. And I'd like to just start with just a couple of housekeeping items before we get going. We do make our content available post-event on our AWS SlideShare as well as our YouTube channel. So folks that ask for our presentation materials, you can find them there. We'd also like to remind you that we have muted the phone lines, but we invite you to ask questions anytime during this webcast, and we'll take some time at the close to answer your questions. I'm pleased to be joined today by Robert Scheer, who's the President and CTO of Greystone Solutions, who is an Amazon Web Services Consulting Partner, as well as Vikram Garbalotti, who is our Solutions Architect with Amazon Web Services. Our key focus today will be a discussion about the benefits of running Microsoft SharePoint on AWS, as well as mapping SharePoint scenarios to AWS and Greystone strategic solutions and some customer use cases. And as I said, we'll wrap up with just a few minutes of Q&A. So without further delay, I'd like to introduce you to Robert Scheer and Vikram. So Vikram, go ahead and take it away.
Thank you, Sherry. Good morning, good afternoon, depending on where you are. So today's webinar, I would like to focus a little bit on Amazon Web Services upfront to discuss some of the traditional enterprise challenges and then how Amazon Web Services helps with that. And then we'll talk about our infrastructure a little bit and then get into how to deploy SharePoint on Amazon Web Services and what are the various components that can help with it. Just navigating, hope everybody can see the slide. So today's enterprise IT challenges, I know most of you on the phone can attest to, meeting growth is one of the biggest challenges. In order to meet the growth, you have to be flexible, you have to be scalable, and your environment has to be elastic. And then the time it takes to obtain a new hardware, racking the new hardware, and doing things with it is definitely a time-consuming effort. So the amount it takes to install and configure is another thing. So traditionally, I've seen environments where it has taken anywhere from 6 weeks to 3 months to at least get the basic hardware set up run. And that's one of the biggest challenges that kind of restricts the growth. Data center limitations, around internet providers, power, cooling, all some of those are, quite other challenges in this space. Inflexible architectures of the application. So this is another thing. We have a lot of these traditional applications that we've been maintaining, managing. We have some of the Web 2.0 type applications that are that can horizontally scale and help. So the traditional applications, like the relational databases, can only go up to a certain point when you can scale them vertically, but they can only get to a certain point from a hardware limitation standpoint. And there are applications that are pretty tightly integrated into the hardware, meaning they would not allow us to scale horizontally as easily as we can do with some of the newer web application type scenarios. So there are limitations and opportunities where you can re-architect them by using new platform choices, but you're kind of stuck with the existing hardware and existing data center limitations. Lastly, but not the least in the discussion is hiring and maintaining the talent. Let alone having them do the ongoing operations work. Having to deal with outages, trying to meet the SLAs, trying to meet the uptime requirements, and it's a lot of effort. And a lot of enterprises end up hiring talent that can span across time zones, span across various geographic locations, and to meet their data center requirements. And then disaster recovery and HA. Obviously DR is another big thing. Depending on your business requirements, you may end up setting up multiple data centers across geographic locations. And in order to maintain them, just purely from the purposes of having a DR is definitely going to be an expensive proposition. So these are some of the traditional enterprise IT challenges, and Amazon Web Services is basically born to solve some of these problems by providing you with a lot of key benefits. We'll talk about some of those benefits. The first and foremost is basically the no upfront investment. Pay only for the infrastructure as you need it. With the traditional infrastructure, you have to guess how much capacity you will need over the next 3 to 10 years time period and pay for most of it all at once, like a capital expenditure. This ties up the money that you will be spending on other things, and it's very difficult to forecast accurately over such a long period of time, what your workload is going to look like, how your business is going to grow. Some of those predictions are not easy to do. So with AWS, you only pay for what you need and what you use. That's the biggest advantage, with the platform. The second thing is, low ongoing costs. Since we invest and operate at such a high scale, we pay less per unit than most anybody else in the IT industry. We can attest to that. If you have been following the platform, our releases, we have been reducing prices over a period of time, and we pass on those benefits to our customers whenever we see there is a cost saving, that we can get by operating at a large scale and streamlining the operation. So that's a great benefit. So you could expect the cost to go down, but never to go up. We run our business on a high volume, low margin business. Amazon is great at that, which is also a quite unique skill that we have. The combination of high scale and low margins basically allows you to pass significant savings to all customers. Like I talked about the number of price reductions we have done over a period of time, it is an example of that. The next one is flexible capacity. With the elasticity of AWS, you no longer need to forecast demand and buy upfront. This is something that we talked about. One of the enterprise IT challenges is how are you going to plan for your applications peak? What does your DA look like? What does your HA look like 3 years from now? Some of those things are pretty hard to predict and manage. So whether you're dealing with annual spikes like the December retail boom, which Amazon has quite experiences with that, or your monthly processing, your quarterly processing, financial closures, period endings, and so on. There are in every enterprise I've seen have workloads that vary across the time zones and then the time periods with varying workloads and unpredictable spikes associated with your applications. The demand changes all the time, and cloud has a considerable advantage over the traditional IT investment model, where you can tap into the capacity that we provide for those peaks to manage your workloads. Speed and agility. This is, with the traditional infrastructure, it can take weeks to get, like I said, server procure, deliver, running, configuration, installation, and all those things. Long timelines. With cloud computing, you can provision resources, you need them. You make a simple web services call, launch a server, whether it is a Linux server or a Windows server, you'll have it within minutes. You can deploy hundreds, even thousands of servers in minutes without, taking any time. And it's a pretty self-service environment, works with fairly easy web services, and you can quickly develop and deploy applications, and allows your team to experiment more quickly and more frequently. If you're setting up multiple environments, whether it is a dev environment, test environment, staging environment, or even production environments, it takes minutes for you to set up those environments, automate the infrastructure, and have your applications deployed on them. And applications, racking and stacking gear in a data center, just doesn't help when you win some of your competitors. It takes a lot of time and a lot of money to, and becomes a big distraction from activities that you can truly differentiate. AWS enables, lets you shift resources away from data center investments and operations and move them to innovate new projects, whether it is, the change request for your systems that has been pending for months now. Some of those low-hanging fruits that you always wanted to, build from an application standpoint. Now you can direct your resources to kind of focus in those areas rather than having to focus them on day-to-day infrastructure operations. You can have your IT and engineering resources focus on projects, that really help your business rather than, an ongoing operation, which is a key differentiator here. Global reach. So we have, 9 regions across the globe. So think of it, you have a readily available infrastructure. Think of it as 9 data centers across the globe, ready to go for you, for your applications. Since we have invested in facilities around the world, We can offer you, global reach at moment's notice. It's pretty cost prohibitive to put your own data center, where all your customers are, trying to figure out, your latency requirements and locations and regions, and trying to, investigate what's the best location and so on. These are all, cost components for you to be able to, create that blueprint. But with AWS, you get the benefit without having to make the huge investment. You can easily deploy your applications in any or all of the 9 AWS regions across the world. This means you can provide a very low latency and a better experience for your customers with no cost. Excellent. So going into the the cloud infrastructure, we have. I'll just talk about the stack a little bit. Here we have at the bottom we have our global footprint, our infrastructure we just talked about with 9 regions. We have on top of it we have our compute services, which is EC2, storage. We have a block store and an S3, which is our object store. Network, we have EC2 classic network and a virtual private cloud. We'll talk about that in the next few slides here. We have relational databases as an RDS as a service, which is managed services. On top of these, we have put together various other services for parallel processing, which is an Hadoop implementation of Elastic MapReduce. We have data transfer services like import, export, VM import, storage gateway. They all work, help with transitioning data from transferring data from your traditional environments into cloud. Or we have content delivery services, which is CloudFront. We have edge locations spread across the globe to deliver the content. Application services, notification, workflow, and email services that you can tap into. Search services, using our cloud search. On top of it, we have our authentic IAM, which is our authentication and authorization service. That's you can define policies, groups, users to work with the services. We have monitoring services like CloudWatch, which gathers metrics on all the underlying infrastructure components, and then also our application services. We have deployment automation tools like CloudFormation, Elastic, Beanstalk, which more or less like a platform as a service model where you can quickly deploy your applications without having to worry about underlying infrastructure. We have libraries and SDKs that you can build or integrate into your applications. We have a management console web interface, which does most of the job and most of the services. Pretty easy and simple to work with. We have tools that integrate into dev environments like Visual Studio Toolkit, like Eclipse. We have a toolkit for Eclipse and for the developers who are very familiar with those development environments. We have command line interface tools for administrators who want to run quick scripts and command line commands to manage the infrastructure and so on. Our AWS Global Infrastructure, 9 regions, geographically located, 3 in U.S. We also have a region which is an ITAR compliant GovCloud region, which is an ITAR compliant region. We have various regions across the globe in Tokyo, Singapore, Australia, Europe, South America. So how does Amazon machine image? What is an Amazon machine image, and how does it work? Everything starts off with a basic machine image. The machine image could be a simple operating system, that either Amazon or a third-party provider can put together, or you can also build your own machine images depending on your application configuration. A machine image includes the base operating system, any service packs or any patches that are required to be added onto it, and then any applications that you have deployed. And using the base machine image, you'll be able to launch multiple instances from it. The instance can be in a running state or a stop state. In stop state, you only pay for the storage. Running instance, you pay for the compute. And then you can launch those instances into either classic EC2 environment or a VPC environment. Attach the block storage, which is basically your volumes, your D drive, E drive, whatever the data volumes that you would need, the size of the volumes that you would need. Attach them to the instances. You'll be able to take snapshots on those block stores to store those snapshots. We use S3. And then we also have an HTTP-based endpoint storage, which is S3, an object storage that you can store your data into. We'll talk a little bit about virtual private cloud. AWS resources. You can launch resources in a virtual network. You can define an environment that closely resembles to traditional environment, meaning you can set up like different subnets, VLANs, to better manage your routing. You have control over IP addresses, ranges, and subnets, gateways, and you can also set up VPN tunnels into the virtual private cloud environment from your on-premise environment. So a typical, an architecture diagram would look like this. You have an enterprise corporate data center on the left, and you have a secure VPN over the internet into the VPC environment. And within the VPC environment, we have multiple subnets, IP addresses that are not advertised to the internet, and then we also have a public AWS cloud, which is accessible over the internet. So we can discuss certain scenarios about setup of the SharePoint, either in a public EC2 classic environment or within a VPC. So this particular slide, we're going to talk about how we set up SharePoint within a VPC environment. The ideal process would be, create a VPC with a defined IP range. So whatever the IP range that, a non-overlapping IP range with your on-premise environment, if you ever want to set up a VPN tunnel, obviously. So you choose the CIDR block that you would like to, have the VPC set up with, and then define an internet gateway, define a virtual private gateway. I obviously want to span multiple availability zones from a HA perspective. Create distinct subnets, create load balancers in each of the availability zones. These are some of the basic building blocks for a SharePoint deployment within the VPC. As far as running Microsoft products on AWS Global, we have a partnership to support to run Windows workloads on AWS. So we offer Windows Server operating system in 2008, 2012. We offer SQL Server with the RDS service. You can also bring in your own SQL Server and deploy in the EC2 environment. We have Windows machine images developed by Microsoft and AWS that are readily available for you to launch. As far as SharePoint Server and other Microsoft products like CRM or any other products, they can be licensed to run on AWS environment. And today we offer pay-as-you-go license model as well as bring your own licenses. So the licensing information is available on our license mobility site at aws.amazon.com. Strongly encourage you to go and look at that on what you can do with a pay-as-you-go model and what are the products that are available for bringing your own licenses and so on. SharePoint common workloads. I don't want to go into details on how SharePoint is used, but basically we already know that it's an enterprise collaboration content management tool. It's used for web applications to deploy your custom web parts and so on. We have search services, SharePoint that provides. So the two SharePoint scenarios that I would like to talk about quickly, and then hand it over to our partner there. So intranet SharePoint on AWS. This is basically a pretty common scenario where you have a SharePoint environment within the enterprise, and you want to extend it into a cloud environment from a scalability perspective, elasticity perspective, or you want to set up different environments like dev environment, test environment, and staging environment for your on-premise SharePoint environment, which is basically your production environment there. Your architecture would look like something like this. You have a traditional load balancer, a domain controller, your typical web server front-end group. You have application servers, and you have the database servers, primary and a secondary with the failover options. As far as the public website goes, it's a hosted public website application. You may want to run this completely in AWS environment. It doesn't have to be a hybrid solution. No dependencies on the infrastructure back to the corporate center. In this scenario, you have a DMZ type setup with the public subnets, and then you have basically your application hosting environment with the web servers, app servers, and database servers in a private subnets. Sorry, I'm skipping a couple of slides here because I'm going to talk about that in the architecture diagram. So a typical intranet network. So on the left, we have your corporate data center and on-premise environments with Active Directory domain controls already existing, doing authentication for your applications, and using your customer gateway and then the virtual private gateway. We have set up a VPN tunnel here, and then within the VPC we have a load balancer that is set up to receive the requests from the users. And then everything is set up in private subnets. Your web tier, your application tier, and then your database tier and Active Directory are set up in a private subnet. So there is no public exposure here and the public components here. So everything's your users are coming in over the VPN gateway to access the SharePoint that is set up in the AWS environment for an internet scenario. For a public-facing scenario, it's a little different. So there's no, as you can see, there's no VPN tunnel and a virtual private gateway here. Users are coming in over HTTPS to the Internet gateway and then to the load balancer. And then the load balancer is sending the traffic to the web tier that is set up in private subnets, as well as the application tiers and then the database tiers. As you can see, there's an additional DMZ layer here. This is from a management perspective. If any of the systems that are in this private network would need to go out to the internet to get updates or for any other resources that they would need on the internet, they would go through the NAT. And from an administration standpoint, if you would like to RDP into any of these servers and do the patching or management or any of those activities, there is a RDP gateway set up in the DMZ environment. So you're basically exposing only these two resources in the public subnet, but the entire system is set up in the private subnets. So Active Directory, with the Active Directory for internal applications, obviously you can use ADFS or set up replication in the environment. Security setup to enable appropriate access in and out of VPC subnets. There are two core components in the security. One is the security groups that allow access into the various ports, and then the network ACLs where you can control the traffic. So deploying SharePoint form in simple, easy steps. Some of the architecture details that I talked about. We have done an extensive work on this in this area. We have published our SharePoint white paper. We have also published a lot of reference PowerShell scripts, CloudFormation templates for our customers to be able to use them and quickly launch and build the architecture that I spoke about, whether it is an intranet or a public-facing scenario. So I strongly encourage you to take a look at that. It's available at aws.amazon.com under articles, where we have clearly defined a CloudFormation template with 4 different steps. So with that, I'd love to hear what our partners have done with SharePoint 2013, and I will transfer it to Bob.
Thank you, Vikram. I'm Bob Shear. I'm the president of Greystone Solutions. Our company designs, builds, and deploys systems that people use at work to make them more efficient and effective, and we hope make their lives a little easier. We focus from a technology stack point of view on the Microsoft platform, and for the last 5 years we've been working with Amazon Web Services. We're an AWS Advanced Consulting Partner, we're an AWS Channel Partner, and we're Microsoft Gold Collaboration Partner. We've talked a bit, Vikram's talked extensively about AWS and to some extent about how to lay SharePoint on top of AWS. I'm going to look at the same topic from a slightly more higher application level and then relate it back to some specifics about SharePoint 2013, some things that we've found work, and some things that we've chosen to set aside for another day. So SharePoint's been around 13 years. By some counts, over 3/4 of mid-size and large enterprises use SharePoint. One of the striking things about it is that if you meet a knowledge worker on the street and you say the word SharePoint, they'll recognize it as a product. There's not really a lot of behind the firewall corporate and information system products like that these days. I think that if you said WebSphere to a bunch of people, they wouldn't necessarily recognize it as a product or a product family. Over the last 13 years that we've been working with SharePoint, we've seen it develop, really rich and deep capability. Starting at its beginning as a little lightweight collaboration tool and a document management tool. It's got all sorts of stuff around application enablement, around knowledge management, business process management, lots of stuff. The problem with this is a problem that you could see from Vikram's last slide. It was this takes a lot of computing horsepower, and it's the pain points associated with that computer power and schemes for resolving those pain points that I'd like to talk about in the next few minutes. The specifics are, first of all, even a relatively small SharePoint environment, if you're going to follow best practices in the Microsoft reference architecture and some of the pretty nice reference information that Amazon's been able to provide, you see that you get into relatively sophisticated multi-server topologies quickly, and these topologies need to be designed and managed. The computers that are part of this topology, instance, virtual or physical, need to be connected in an appropriate way. They need to have their security appropriately configured. They need some nuanced detailed configuration around things like server principal names. In addition, you're now faced with the question in the world of SharePoint: how do I plan this? How do I plan an appropriate capacity? In the world of physical servers, or even in the world of virtualized servers, one of those cute little diagrams with 8 or 10 boxes on them can be tens or hundreds of thousands of dollars worth of electronic stuff. And as Vikram said at the beginning, we're always faced with having too much of the time, and not enough some of the time. So facing the possibility of significant capital investment and thinking about the problem of capacity planning, I'd just like to point out that the capacity planning problem in SharePoint is harder than the capacity planning problem in most enterprise systems, because the nature of the workload is soft and so dependent on human behavior. If we have a business system that can be related to the number of transactions or the number of customers or the number of visits, we can do some relatively straightforward computation. SharePoint has got a history of having great uptake in certain environments and weak adoption in others. It's a pity if the weak adopt during periods where the adoption is weak, the thing's fast enough, and as soon as people find out how to use it, it melts down. So the problem of the kind of two-headed problem of capacity planning and capital investment is another challenge that we who architect and build SharePoint systems confront. And finally, and this, I think if you're doing work that involves extending applications, workflow, business process management, the best practice is around having high fidelity development, testing and staging environments. The fact is that the cost and burden to create these environments in SharePoint can be sufficiently significant for all but the largest budgets, so that the ideal of a high-quality test environment is theoretically possible. From a practical point of view, it isn't. Now, that's SharePoint as it's evolved over the last decade. SharePoint 2013 has got a lot of really wonderful, interesting, advanced capabilities and improvements, and these improvements take more horsepower, and that horsepower makes the pain more acute. The solution to the solution to these problems are, lots of carefully executed details in the final analysis. But if I had to think about the kind of overarching idea that allows AWS to turbocharge and enable really effective SharePoint and SharePoint 2013 solutions for us, I would encapsulate it in the single word agility. And as this slide says, AWS endows SharePoint with agility. Back not long after Amazon first released to production what was then, I guess, a Windows 2003 server running on AWS, we had been using AWS for development work, helping people do pilots for startups, and a company came to us that's a private equity firm. They had spent a long time building a new kind of really high quality, deep, public-facing website. It was internationalized, localized, 6-language, big thing, and we were ready to deploy it. The site was being hosted by a very high quality engineering and hosting company. And they told us that it would take 2 months to do sufficient infrastructure upgrades to put the thing into production. We were in more or less hand-to-hand contact with these kind of really high-quality, careful SQL Server DBAs who had a hard time adapting their rules of SQL Server governance, which were set up for financial transactional systems, to an environment where SQL was basically just a durable backing store for SharePoint. In addition, our client did not want to go into production without understanding the performance characteristics of this public website, as loads may develop over time and at different levels of computational power. This involved setting up, kind of procuring and installing, a fair amount of temporary hardware. We suggested that why don't we at least take a look at the performance, get a proxy for performance at different configurations by setting it up on AWS. The client said that's a great idea, and 1 week later, it was up and running. After a week or two of hemming and hawing and looking at the security and the security posture and policies at Amazon, they said, you know what, this is pretty good. We're going to just drop the hosting service and use AWS. That was 2009. The site's up today. It's adventinternational.com. If you go to adventinternational.fr, you'll see it in French, .de in German, .cn in Chinese, and the like. So the story here is around agility, and that translates into cost and good practices and lots of other things. Now, but we advertise that we talk a little bit about SharePoint 2013 today, and the hour's flying fast, so let's talk about SharePoint 2013. You see in front of you a peculiar, to some of you this diagram may look familiar, and to others it might look just peculiar. It is the geometric representation, an abstracted geometric representation of kind of the core slide that the folks at Microsoft used to describe the investments in and improvements in SharePoint 2013. You'll see on the left there's a long, big block that says user experience. And if you go to the Microsoft website, you'll see well, of course, this whole thing's really an eye chart, but you'll see a long list of really great and interesting improvements in user experience. The other 12 areas are areas in which there have been, significant investments, in which in some cases there's really significant improvements, and some of them, for example, the upper right-hand corner, a new application model that is actually, I think, from a software engineering point of view, going to be pretty important to the kind of longevity and usability of SharePoint over the long haul. Other of these blocks, when it's social in the lower right-hand corner, mobile in the middle, are responsive to the way the world works in 2013. And the way that world works, for example, is that, if you look at 2013 versus even 2010 or 2007, I was struck listening to watching Vikram's two reference architectures. One was the behind the firewall intranet architecture. We can't, 4 years ago, many of our clients said that's what we want. We can't use that today almost anywhere except in the most specialized secure environments. And the reason is that everyone, including the executives of our clients, want mobility, they want ubiquitous access, they want smartphones, they want tablets, and they want those connected to their SharePoint environment. So what I'd like to do is to visit a few combinations of these SharePoint 2013 features and think about how in the AWS environment how we can leverage AWS environment to make that big problem that we talked about, that is the problem of the infrastructure burden, both capital and human, to simplify that. Now, I've identified 5 of the SharePoint 2013 areas as improvement areas, as areas that call out for enhanced horsepower. The user experience, social, mobile, these are all places where these are all points of contact between the user and the system, where the amount of traffic, the burden, the computational burden goes way up just because we've created an engaging and interactive environment in which the user can work. And in that world, the variable capacity that's ours for the asking in the EC2 environment, in the AWS Elastic Compute Cloud environment, is of great value. Now, we don't necessarily use this variable capacity in the same way that you might see it used in a Linux-based world with some really with a lightweight but effective auto-scaling, and I'll explain that in a moment. But the fundamental, and I'll explain it now. Fundamentally, we've got Windows servers. They're in an Active Directory domain. Some of them have specialized functions. When one creates one from scratch, it gets sysprepped. When one joins it to a domain, all sorts of sophisticated stuff happens. We don't want to be creating those and throwing those away on the fly. On the other hand, and that might be really important if I'm trying to make the next Facebook or the next Twitter. But what I'm actually trying to do is to make my SharePoint environment really responsive and really attractive for our users. What I really want to do is to truncate the problem of having to sit down and plan capacity. I have a 2 order of magnitude span of capacity that I can control in the EC2 environment simply by configuring servers and selecting the very smallest to the very largest instance types. I can switch instance types simply by rebooting the server, more or less by rebooting a server, and I can start and stop previously configured domain servers on demand. So putting this together, it's a relatively straightforward. It's a very straightforward matter to slightly over configure and over provision our systems, to amp it up to much larger systems at peak loads. If I'm a university, I want this on the first week of classes and the week that grades are released, and I want to go down to basically a skeleton crew of computers in the month of August, and that can be done. Actually, we frequently do it semi-automatically with some scripting using the EC2 API. Now, that's capacity, really meaning disks. disks and CPUs and memory. But that's not the only kind of capacity we need in the SharePoint 2013 world. There are the interconnectivity that SharePoint 13 allows and that it requires is substantially higher than in previous releases. This new app model is all based on loosely coupled connectivity, what we would have called in the old days portlets, somewhere to a certain extent. There's this new Office Web Application Server, which I'll mention again a bit later. There are connections. Of course, there's always been a connection to Active Directory, and there's connections for search. Today, our average mid-size SharePoint implementation has connectivity to 6 other systems. Some of them are technical connections, like reaching out to vCards in a Exchange environment, but many of them are app-level connections to line of business systems or specialized data stores. I want these systems to be reliable, and I want them to be performant. And if I had all the money in the world, what I would do would be to put my systems as very close to the Tier 1 providers and the Internet backbone as I possibly could. But I don't need all the money in the world to do that. I don't need any money to do that. All I need to do is to host these systems in an AWS environment. And I have inherently in this close to what maybe massive scale, slightly the wrong word, but really massively scaled, close to the backbone connectivity. So if we think about where to cite systems and whether it's important to cite the system at the office or in the cloud, and if in the cloud, which cloud, I think that this is something that's this ability to be so close to the backbone is something that's crucially important, but yet hiding in plain sight. It's okay if we have it's okay to have simple problems. At the same time, it's okay to have simple solutions to complex problems. At the same time, if we look once again at the user experience activities, that there's the need for high performance at the network edge. It's always been a problem with SharePoint. I know Microsoft has worked hard. Back in 2003 days, it was a 1 megabyte JavaScript download for each first visit, and 10 years ago, a megabyte was a lot of data for some folks. What we've found is we've exploited CloudFront in a couple of ways. First of all, CloudFront is proven to us to be a really easy to use, kind of lightweight way to deliver content and a reliable way to deliver content to the network edge and close to our users. And the second thing, just parenthetically, is that one of the things that SharePoint 2013 has added is rich media players. That is something that appears to be video streaming, but it's lightweight video streaming. We've got clients who use it very effectively for things like, the 3-minute training video, how to fill out a vacation request, something like that. But it's missing the features that people expect in 2013. The media servers that are part of CloudFront have that ability, and because of the and by hosting that streaming media on S3, or this rich media on S3, we found a very simple matter to create single-use encrypted URLs that allow a combination of this really high performance, delivery, probably high performance and high functional capability delivery of streaming video to the network edge with the safety and security that most authenticated SharePoint environments require. I've suggested in this slide that certain areas, work management, cloud in the Microsoft parlance may mean integration with third-party, SaaS services. So whether it's a hosted email or a federation with other portals. Interoperability. I said the new application model means that we can, we build applications, as I say, loosely coupled. One of the really interesting parts of this, basically the new application model and search, is document previews. That is, when I run a search, the topic of all the great stuff that's in the 2013 search is a topic for another day. But we get something in SharePoint 213 called display templates. And display templates allow us to visualize a search result or a document, the present document's title, so to speak, and look inside of it. We can look inside Word, PowerPoint, Excel documents with a server called the Office Web App Server. The Office Web App Server gives us lots of great stuff, but it needs its own computer. And it might need two of its own computers. And if those two computers, even if they're virtualized in an on-prem environment, it's a lot harder. You still have to ask permission. You still have to find enough memory. You still have to negotiate whether there's enough memory in the room and enough bandwidth in the building. The need for architectural flexibility and the inherent, in a SharePoint environment, the need to be able to change your mind either for performance reasons or for security reasons or for manageability reasons gives us some great leverage. A couple points to talk about briefly. One is, let's say that I wanted to achieve some of these benefits in principle could be achieved by saying, well, let me just host the whole thing. But first of all, there are a number of SharePoint 2013 features that are available on-prem that aren't necessarily available in hosted versions. Second of all, there's lots of reasons, especially from a control and compliance point of view, that I might need I need to be able to control my own destiny. A couple examples include just archiving policies. I can be faced in a single environment, especially if I'm in finance or in medicine. I can be faced with a single environment where one part of my data must be permanently archived in an immutable form, and another part of my data environment and my data backup, so to speak, must be subject to a relatively strict record disposition cycle where I need to, like clockwork, destroy them after 7 years. How do I do both if I'm not in control of the placement of the data? Likewise, if I have verified systems, whether it's for aviation or pharma, where I need to control a configuration and I don't want to upgrade to the next version of any platform item until I've gone through my whole validation process, I can control that in the AWS environment, and I can't control it if it's hosted. So here I've talked a little bit about compliance, but mostly this is about storage, and it's about the cost and efficacy of S3 and Glacier. Finally, and this is one of the most important things for us here at Greystone, is the ability to create a very high development dev, test, and stage environments, very economically. So we use some scripting and some APIs for that. We use some CloudFormation, but it lets us live the benefits of good engineering practice. So in summary, and by the way, I say this is a summary, but I've smuggled a couple additional points in here. Delivering SharePoint 2013 in an AWS environment delivers performance because I've got on-demand capacity. It delivers close to the backbone connectivity, and it delivers also close to the user data delivery. The part I've smuggled in here, I should say, is the reliability, the geographic diversity. I can't tell you how important to us the the network protection and network engineering is. Even if we take the simplest single zone environments, our customers who we've moved to AWS for SharePoint and for other .NET applications experience. Even if they say if I don't want to pay for it, I can't afford any sort of disaster, special disaster recovery. They all get as much as in our experience over the last couple of years, maybe a 5 to 10x improvement in availability. Maybe they're down 3 hours a year instead of 30 hours a year. And finally, engineering capabilities around control of the data at rest. Configuration management, and I said earlier, high fidelity dev and test environments. So that's our story. You can, if you'd like to learn more about what we do, my colleague Adrian Ducille be happy to take your call. You can visit us at www.greystone.com. We have we've developed some specialized training, kind of person-to-person, kind of high-touch training around building out Windows environments in AWS, and we also have a quick start. Not every project can be done in 1 week, but we've got a lot of experience in doing projects that one would think would be 3-month projects in 1 week. So give us a call if you'd like. I think we have some questions. Sherry, thanks so much. Back to you.
Thanks, Bob, and thanks, Vikram, for a very detailed overview of some of the key benefits of running SharePoint 2013 on AWS. We do have a few moments for some questions, and we've got some in the queue already that we'll take here now. So this first question I'm going to direct back to you, Vikram. The question is around, on a VPC, what's the address space supported? This person is asking if it's only an RFC 1918, or is it beyond that? Can you address that?
Yeah, it is RFC 1918 today.
Great, thank you. Another question is along the lines of, does AWS offer another authentication method such as SAML, or if a client does not want to connect via the VPN tunnel, so is there another way to authenticate?
So it's a great question, especially in the context of SharePoint 2013. There's been a lot. Let me answer it in a couple parts. First of all, as I said before, even though we exploit VPN tunnels, or VPC in the AWS parlance, for connectivity back to the whatever's left on premises, that does not. It's frequent today that authentication is. In fact, the most common cases, there is no VPN or VPN control up to a SharePoint site. On the SharePoint side and on the Windows 2012 side, there's lots of great work that's been done to enable SAML and SAML 2.0 federated identity. One of Amazon's partners, Ping Identity, does some really nice, kind of lightweight, high-power work on that line. We build out federations with other, SAML providers, not infrequently. And finally, in terms of general identity management, the capabilities of IAM to integrate with and federate with and extend not only Kerberos/Active Directory authentication, but other authentication schemes is powerful. So the punchline is that your users don't need to use VPN. They don't even need to, if you're careful about security, you don't need to use VPN if you just need a remote desktop. And there's all sorts of other features at the architectural level if you're trying to federate or leverage anything from an Oracle Identity Manager on down. I hope that answers the question.
Thanks, Bob. This next question, Bob, I'm going to point back to you, and Vikram, feel free to join in as well. This person is asking if you have experience using other AWS services. I know that you talked about EC2 and CloudFront, but specifically besides EC2, maybe VPC, S3 in SharePoint environments, are there other AWS services that you've utilized?
Yeah, we, well, of course, our engineers here kind of think of it as being in a toy store, so they at least try all of them. But in the context of our use of SharePoint 13 and the general Microsoft stack, there's big things and little things. I mentioned briefly CloudFront, CloudFormation, pardon me, which helps us configure systems, and we do leverage the API. One of the tools that we've been, or one of the services that we've been really excited and happy about is Route 53, the DNS service. It's almost completely denial of service proof because of the scope of Amazon's the size of Amazon's infrastructure. It's also got lots of benefits in terms of its latency aware routing capabilities, and finally, because you can manage it through the API, it's got some great capabilities around failover and reconfiguration. A couple little things we actually love. SMS, a simple mail service. We use it for it's just another problem that we don't have to worry about. And I guess there's a.
I just want to add a couple of things.
Please, yeah.
To that. What I've seen customers when they have deployed AWS, it's not just deployed SharePoint on AWS. Sorry, but it's not just the SharePoint as a service that they get benefited from. We have seen customers doing SharePoint farm backups, frequent farm backups directly into S3, and then eventually moving it onto Glacier. Obviously, that's definitely an added benefit. And not only the production environments, it makes it real easy for them to quickly spool dev, test, staging environments and trying different things with it. And like Bob said, SMTP, SharePoint obviously has integration with email, and they have used our SES service for email. And for any custom application development, for example, you're developing web parts or you're developing custom web applications that you're deploying on SharePoint, then you'd be able to use our fundamental services like queue services that if there's a workflow that you want to trigger from your SharePoint application, to either an on-premise application or maybe some other application that is sitting in the AWS environment, you easily use some of our infrastructure, application services to build your web parts. You can use DynamoDB integration with SharePoint. So there's a lot of opportunities there once you have built the environment within the AWS environment.
Absolutely. Actually, and Vikram, as you're speaking, it came to mind first of all that we have got. We're pretty happy with the use of Storage Gateway for delivering kind of low-cost raw storage to the office and having it safe and reconstitutable in the cloud. And we also combine. We make extensive use of CloudWatch. It's frequently combined with kind of some of the fancy System Center-based monitoring tools from Microsoft.
Great. Well, I think we've got time for one more question. And this question, I'll point back to you, Bob, to chime in, and as well, Vikram. So the question is, Microsoft provides some limited support for SharePoint stretch farms. How does AWS ensure latency across availability zones is limited to minimize any performance impact?
Start with Vikram. That's a complicated question.
Yeah, I can take that. I mean, definitely Microsoft provides limited support for SharePoint stretched farms. I mean, obviously the idea of the design goal here is you're distributing across multiple availability zones, and the fundamental infrastructure building block that we provide is, for a high availability architecture is we have to have the availability zones separated out with the different internet providers and different electricity providers, which gives a lot more flexibility from a failover standpoint or a high availability standpoint. So obviously there are some trade-offs that needs to be done here. I'm not an expert in Microsoft support models or licensing models, but I understand they only do it if everything's kind of located in a single data center, which is again a single point of failure. What we are trying to avoid is to have the systems spread across in multiple AZs, and our obviously it may be a little different from different AZs, but we have all our AZs are connected in a network, and then the latencies that we have seen are pretty very minimal, and the application should perform really well in that scenario.
I know we're out of time, but just to add one word to what Vikram said, in our experience, interzone latency, which while certainly noticeable, is less than I find within the computer room within some enterprises. So faster is better.
Good point to close on. Well, on behalf of AWS, I'd like to thank Bob Shear, President and CTO of Greystone Solutions, and Vikram Garbalotti with Amazon Web Services Solution Architect. And on behalf of all of us, thank you for joining. And before you drop off the call, we do invite you to take just a very quick survey, give us some feedback, let us know how we did, where we can improve. And if you've submitted questions and we haven't gotten to them, we will follow up with you directly offline. So thank you again for your time, and have a good day or evening wherever you are.